Okay, so as long as it makes sense logic, so there's no standard way to draw. Yeah. Smelly, yeah. Very smart, very smart. Okay, so let's move on to the second tools. How do we represent the knowledge? Okay, so the second method is known as a conceptual graph. So as I mentioned, conceptual graph is quite similar to the semantic networks. Both of the conceptual graph and also the semantic network are used to represent the relationship. But anyhow, the conceptual graph is more formalized, or it's more, it supports the first order logic predicate. But unfortunately, we are not going to cover the first order logic predicate. So you can actually temporarily forget about what is conceptual graph, but I will just let you know how to draw the conceptual graph. What is the difference between the conceptual graph and also semantic networks? So semantic networks, we have a node here to represent the concept, right? Then we have a label art. It shows the concept too. Alright, so then we have our relations. So you can see the syntax for the conceptual graph here. Instead of using so-called the label art, we are going to use a node to show the relations. That's it. So that is the difference between semantic networks and also the conceptual graph. Okay, so this is the difference between conceptual graph and semantic networks. Just for information, we didn't cover the first order predicate, so that's why you may find out that it's very difficult a bit to understand what is meant by all these things. But you can see the patterns, the way that we represent the relation is pretty similar to the semantic networks, but only difference here is the relation here. Yeah, relations, we use the nodes to represent the relation. So that is the only difference that you need to remember at this moment. Okay? Alright, so the third tools that we're going to use it to call an graph is also known as the hypergraph or so-called inference language. It's quite suitable for more to rule-based, yeah, because it's able to arrange the so-called problems and go in hierarchical structure here. Okay, so one of the examples is like this one, right? So assuming you have three different rules. If John smiles, then you look handsome. If John tall and strong, look handsome, and John does exercise, then he is strong. So we have three different rules here that how to form this end of graph. So this is actually an end of graph here. Yeah, it's very simple. You just need to put your goal at the highest level here. So the highest level is handsome, right? And then you have to find out what is the conditions that used to support the goals here. You have small, tall, and strong. So that's why you have tall, strong, and small here. Right. So you may find that why there is a linkage. If you have n here, tall and strong, then we just need to add one more linkage here. Yeah? If they are dependent or we use all, then we don't put anything. Okay, and then he does exercise, then he is strong. Does exercise, then what is the conclusion? Then he is strong. As simple as that. Yeah? As simple as that. Yeah, you get full marks. Okay, so try this exercise. So this is one of the partial questions. You have three different rules here, and you are required to develop an or graph based on the rules given above. So I give you 3 minutes. 3 minutes trying to solve this problem using an or graph. Yeah, 3 minutes.
If this world were mine.
Okay, so we will start with the rules number 1 first. So what is the conclusion for rules number 1? This is the conclusion. The overall condition of the car is poor. So at this moment, forget about the CF here. So CF stands for certainty factor. We will learn what is certainty factor in the chapter 12. Okay, so rule number 1, the overall conditions. overall conditions of chi-square. Overall conditions is poor. Right. So what are the so-called conditions to support the conclusion? The car exterior is poor. Interior condition also poor. Exterior is poor. Interior is poor. Right. So we have these two conditions that used to support the conclusion. So we are using all. So we don't put any link here. So rule number 2. The overall condition of car is poor, same conclusions, so we're finding the same conclusions. The car model is X6. X6, 150K. KN. Okay, engine is noisy. So we are using N, so we just put a link here, as simple as that. The last one, do not buy the car. Right, so we have one more conclusion, do not buy the car, and one of the conditions is actually a conclusion here. The overall condition is poor, the car service does not follow. The car service does not follow the schedule. Okay, so and again, so we just put this. Do not buy the car. That's it. Yeah. Right. Rules 1, rules 2. Okay, do not buy the car yet. As simple.
Do not buy the car. The operating condition of the car is poor. The car service
Okay,
does not
2 marks.
follow the maintenance schedule. The car mileage exceeds 150,000 kilometers, and the car engine is noisy. And the overall condition of the car is
Okay, so this is the solutions for this one of the past questions. Just need to identify which one to go, which one is your condition. Then you just somehow join it, and always make sure they go away put at the top, and the condition is put at the lower, so they are put in the algebra structures kind of
and
thing.
the overall condition.
Okay, so the last one, springs. Are you guys are all RSW students? What class diagram?
No.
Yeah, so this spring is quite similar to the class diagram where we are trying to organize all the data into a kind of tables. Okay, so yeah, so this is one of the examples here. So we have 2 frames, right? So we have a computer is the name of the frames, and it's actually a class. So it's a super class, then we put it's a class here. And so this is all the slots. And then we don't have a value, then we just be blanks. Alright, so let's say we have ASUS. So there's a mistake here. So ASUS is to be a subclass. Yeah, ASUS is a subclass to the computer, and then these are the slot as well as the properties, the value here that refer to the properties. Right? And this one shows the inheritance. So the ASUS value inherits all the properties from the computer, as simple as that. Okay, so we have done this in the class diagram. Just read. This string is also quite well-known tools that we use in the NLP system. Okay, so one is advantage is the structures are organized. Yeah, so represent as real types and is able to describe various attributes and the characteristics in more details compared to the semantic language. Yeah, semantic language we are not allowed to. It is quite challenging to use the semantic language to represent object when you have a lot of properties and you have attributes here. So usually we use the frames. Okay, so make sure that you have 3 important elements: the name of the frame, right? So and then inherit from which part? Yeah, it's a superclass, then you put it's a class here. Inherit from other class, then you have to put it's a, and then you have to put the class that you inherit. Then you have attributes or slot, and then you have a value as well. Okay, so this is more examples. Yeah, bird is a class, and then what is the values here? So values we have a price. Ostrich is a bird, right? It's example, right? You put instead. And to the examples, Fred also an example to the ostrich, right? That's it. Okay, so you can extend this string to form more information where we include the data type, which is strings, maybe numerics, or maybe string here. Okay, and then we can add as well the faces, for example, whether it's a default value, whether this is initial value. But whether you put a data type or you put a default or initial is optional. The most important the elements that you have to put is the name, the frame names, slot, and the values. Right? So what is the advantage for the frames? It's more flexible, it's able to store inheritance and able to store all the properties. But the disadvantages for the frame is not able to show the flow, the sequence of the event, just like the semantic networks. Okay, so let's cover a little bit more details. What are the things that we can store in the values here in the slot? So we can store the values, right? In this case, we can store, okay, for example, the height is 2.7, so we can put the values. We can also put a description here. They are not necessarily a value, not necessarily a numeric, but it could be a description. And sometimes one of the slots here could be a class. That should be a class to another frame here. For example, in this case, one of the slots here, managers. So actually, you can expand this from managers to another class to describe more details about the slot here. Okay, and the last one will be the procedures. This is like the methods in your class diagram. It's a method. Yeah, right. But in NLP, we rarely use the elements or the procedures. Yeah, we always use only the slot and the values, but not the elements. Okay, so yeah, we have a few more slides here before we end the class. Right, so assuming that you have a semantic networks here, so how to change into the frames. So this is one of the type of a famous question as well. You have a type of a semantic network, so how can we convert into the frames? So how to convert is pretty simple. You just need to identify how many frames that we need to generate based on the keyword instant and is a. So we have a team, is a join to the player, join the Ronaldo, so we can just treat 3 frames to represent Ronaldo, player, and the team. The remaining here is just treat it as the properties or the attributes. Right, then we can just convert. We have a 3 frames here, team, players, and Ronaldos, and the remaining are just the value and the slot. That's it. So this is how we convert the semantic back to the frames here. Okay, same goes to this one. So how we convert this semantic to the frames. So identify how many concepts that join to by the instant and insert. We have a 3, so we have 3 frames. There's no answer here. Okay, I think I have one passive question from Stickins.
Partial question. Partial question. Partial question. Partial question.
Chicken Mantilas sauce lemon mayo.
Sauce lemon 酸的。
开胃。
哎呦。
Okay, so can you try how to put this knowledge into frames?
有什么东西要？
Yeah, so we have a 2 sport here, badminton and swimming are parallel for sport among students. So badminton is a racket sport, play using a racket and this shuttlecock and blah blah blah. So I give you 10 minutes, right? Try to understand this paragraph and how to convert this knowledge into frames. Okay? I think, but first thing first, you need to identify that how many frames that you should create first. Okay, in this case, sport, this sport will be one of the frames. Badminton, another frame, swimming, another frame. So in total, you should have 3 frames here. Okay, and then you need to spot the attribute, the properties, and then just fill in the blank. Just fill in the blanks into the frame.
Badminton and swimming. 为什么呀？我相信E5了，相信E5。你讲什么？
几分呢？什么呀？一颗吧。别放松来自。还是想要。
珍惜生命，从你我做起。 谢谢你。那你给他这个？
没有，
不是你给我吧？
对啊，没有啊，在之前给我。
哦，没有爱啊，没有爱啊，
都有啊。
太多爱了。我们的任务真的要做，我们直接随便找一个队友啊。啊？忘记谁啊？啊？就啊。可以。我在那个游泳 group 那边问哦。
管
Anyone?
no good yet，没有人讲话。
是没有人讲话。Haven't from
什么鬼班都有。
notebook group。
就是跟那些奇奇怪怪的不一样啊，我了解一个给你。We need one moment.
Girls will be
Girls is prioritized. No sure.
哎，如果我真的生的话，我就很糗。等下我要讲见人。
今晚来了没？今晚来了没？全部人。
我不懂哦。
30个人哦，我们班。
要问你要挂水。
没有啦，都没请完呢。
这个比较胖胖样子啊，这个好看这个。
哎，你懂哦，我们 Tokyo Day 哦，至少3个人一 team，至少一个女的。
哎，好吧。
This is prioritized. 可以了。我室友不是 Tokyo 的，他只是单纯来游，然后被拉去来干那边哦。刚好跟我们你没有跟我们啊？他刚好跟我们同一个时间，刚好一起游，然后结果当第一天就被拉去来干那边了。
很难排的嘞，社群那点，很难。没有，我不敢拍，等下跟他姐姐们讲。他电话拿着，懂了密码。04。这个，这样都给你刷到了。太冷了。Instagram。6号。